All right, so static testing finds defects directly and dynamic testing finds failures first?
Exactly. And static testing can catch issues before the code even runs, like unreachable code or security flaws. A strong testing strategy always uses both.
Two sides of the same coin. Bob and Sarah compare static and dynamic testing. All right, Sarah, I think I've got the basics of static testing, but how does it really compare to dynamic testing?
Good question. Both types of testing aim to detect defects, but they do it differently. Static testing finds defects directly. Dynamic testing finds failures and then traces them back to defects.
Right, so with static testing, we're analyzing the work product itself, code, documents, or designs, without running it. With dynamic testing, we execute the software and observe its behavior.
Exactly. And that leads to another key difference.
Sarah writes, static testing can find defects in rarely executed or hard-to-reach code paths. Oh, that makes sense. Some parts of the code might only run in specific conditions, so dynamic testing might never hit them. But static testing can still uncover issues there.
Right. And there's another key distinction. Static testing can be applied to non-executable work products like requirements or architecture designs. Dynamic testing, on the other hand, only works on running software.
So static testing isn't just for developers. It's useful for business analysts, designers, and even testers reviewing requirements.
That's why we involve a variety of stakeholders in static reviews. Static testing helps with maintainability. Dynamic testing helps with performance.
Oh, I see. If I want to check whether the software performs well under load, I need dynamic testing. But if I want to check whether the code is well structured and easy to maintain, I use static testing.
Now, let's talk about the kinds of defects that static testing is particularly good at catching.
Defects in requirements, ambiguities, contradictions, omissions. Wow! Catching these early must prevent a ton of issues later on.
Exactly. A misunderstood requirement can lead to a feature that doesn't meet user needs. Fixing that late in development is costly.
Design defects, like poor modularization or inefficient database structures. So static testing can help make sure the software is well architected before we even start coding.
And it also helps with coding defects, like unreachable code, undefined variables, or code that doesn't follow standards.
Oh, I bet developers love hearing about those.
Maybe not at first, but in the long run, it saves them headaches. Also, static testing can catch incorrect interface specifications and security vulnerabilities.
Oh, I see. If two components need to communicate, but one expects 3 parameters and the other only sends 2, that's an issue, right?
Yep. And that kind of mismatch is easier to catch with static analysis tools than by waiting for a runtime error.
Security vulnerabilities, like buffer overflows. So static analysis can also help spot security risks?
Exactly. It's a great first line of defense against security issues.
Wow, so static testing can catch a lot of issues before we even run the software. But that doesn't mean we can skip dynamic testing, right?
Not at all. They complement each other. Static testing catches defects early, and dynamic testing ensures the software behaves correctly when executed. That's the key takeaway. A good testing strategy uses both.
All right, Sarah, I'm starting to see the big picture. Let's keep going. I want to know how to apply these techniques in real projects.
What happens when stakeholders give feedback too late?
A disaster. We'd have to redo everything.
Exactly. Early and frequent feedback helps prevent misunderstandings and ensures we're on the right track before it's too late.
All right, I see why reviews matter. Let's do this. TestTactix, upskill, innovate, succeed. Want to succeed in your QA journey? Subscribe for more engaging videos like this and take your QA skills to the next level.